In April 2024, an entire foundational era of human engineering quietly powered down for the very last time. Zilog, a pioneer in early computing, issued an official product change notification. They announced a last-time buy for the Z80 microprocessor, effectively shutting down its production lines. We live in an ecosystem where smartphones are designed to become e-waste in 24 months. Yet this specific piece of 1976 silicon ran continuously, without interruption, for 48 years. Our hyper-modern world is secretly propped up by a foundational layer of 50-year-old hardware. To figure out why this specific architecture outlasted nearly all its contemporaries, we need to perform an autopsy on its design. If you recognize the Z80 at all, you probably associate it with childhood. It powered the original Game Boy, the Sega Master System, and early arcade cabinets like Pac-Man. But gaming was only its infancy. Right now, you are unknowingly interacting with this exact architecture. It manages the timing of traffic lights on your commute. It processes inputs inside heavy industrial machinery, and it regulates massive commercial HVAC systems. Hardware doesn't stay relevant for half a century by accident. The Z80's longevity came from its ability to shrink and hide inside mission-critical infrastructure, where reliability matters more than speed. To understand how it persisted through 5 decades of Moore's Law, we have to go back to the exact moment it was conceived and look at the architectural DNA burned into the silicon. In the mid-1970s, microprocessor design was dominated by a handful of brilliant engineers. At the top of that list was Federico Faggin. The technology sector was a wild frontier. Companies were frantically trying to miniaturize computing power to fit inside desktop machines and consumer electronics. Faggin was the lead designer for Intel, the undisputed titan of the industry. He created their flagship 8080 chip. But feeling undervalued by Intel's management, he defected, taking a tiny team with him to start a rival company named Zilog. His goal was exact retaliation. Faggin knew every single limitation and bottleneck of the Intel chips he had built. He designed the Z80 specifically to exploit those engineering blind spots. Driven by professional revenge, Faggin's team stripped away the inefficiencies of the Intel architecture. They engineered a processor meant to undercut the market by drastically reducing the cost of the hardware around it. The Z80's advantage was built-in DRAM refresh logic. Memory chips forgot data unless constantly reminded by an electrical pulse. The Z80 sent this automatically. Competitors required complex external support chips just to stop memory erasure. By eliminating these, the Z80 slashed overall manufacturing costs. Saving pennies per board meant millions in profit at scale. Manufacturers rushed to adopt it, embedding the Z80 into affordable home computers and educational terminals. In the microscopic world of silicon manufacturing, the winner is rarely the fastest processor. The winner is the one that achieves the highest economic efficiency. By the 1990s, personal computers demanded massive processing power. The Z80 could no longer keep up with desktop tasks. Instead of going extinct, it adapted. It became a microcontroller. Manufacturers dropped it into devices needing simple, reliable logic, like TI-84 graphing calculators or coin sorting mechanisms in soda machines. Then it moved into high-stakes environments. It was integrated into medical equipment pumping mechanisms, industrial rail network control units, and power plant sensory subsystems. Technology achieves true permanence when it executes code so consistently for so many decades that upgrading it introduces more risk than it solves. Which brings us back to April 2024 and the final discontinuation notice from Zilog. Zilog isn't ending production because the code stopped working. They are stopping because the physical 1970s-era foundry equipment required to print the silicon has finally broken down beyond repair. We have normalized an industry built on planned obsolescence. We buy devices expecting them to degrade, requiring constant software patches and inevitable replacements. The Z80 didn't need to change. For almost 50 years, it remained functionally sufficient for its tasks, requiring no software patches, no updates, and no redesigns. The end of the Z80's production line closes a unique chapter in hardware history. It leaves us to wonder if we will ever design